All right, guys, we're taking a look at a question that gives you this mechanism. You'll notice that I've already done some of the work here, but initially on your assignment, not only does it give you this mechanism, but it lets you know that we're slow, fast, and fast here. All right, but I want you to see what I did. All right, remember, in order for us to do the first thing that or one of the items it wants us to do, which is write the overall reaction, I need to cross out or eliminate intermediates and catalysts, and I do that by finding any reactants that duplicate any products. So you'll see right here, there was an exact duplication of the C4H9+, and right here, there was another exact duplication. Nothing else duplicated from products to reactants, all right? I know you see two waters there, but they're both reactants, so that can't count towards a catalyst or intermediate. So in order to write the overall reaction, I'm going to simply combine all of the stuff that wasn't eliminated, all right? And when I do that, you'll see that I had the C4H9Br. There was two waters. And then on the other side, I brought down bromine, this compound, and the hydronium. All right. Oh, there should be a plus right here. Doot, doot. All right. Another thing it wants us to do is identify the intermediates. Now, remember, an intermediate is an item that is a product that's been eliminated but not in the last step, because it would be a catalyst in the last step. Now, in this case, that doesn't matter so much because nothing was eliminated in the last step, so there are no catalysts here, but it looks like each of these guys will be an intermediate. Finally, it wants us to write the rate law. I know that the rate law is required to include the reactants of the slow step, because the slow step is the rate determining step. Therefore, this is the guy, excuse me, that I care about. All right. However, I know the rate law is also going to require me to include all reactants from the overall reaction. So I need to include the reactant from the slow step, and any reactants not in the slow step, so both of these guys will be present. The items in the slow step that I am including will have an order, the exponent, equal to their own coefficient. If there's any reactants being pulled from the overall equation that are not in the slow step, I'll give that guy an order of 0. The idea being that he is not rate determining because he's not in the slow step. Therefore, up here is my rate law. Again, including the reactant from the slow step, he's got an order of 1 because he's got a coefficient of 1. And then the water with an order of 0 since he's located in the overall equation but not a part of the slow step.